Hi guys, and welcome to winter school finally. If you've been watching the Learn Extra shows, then you would know who this is, and it is Tracy, and the best teacher ever. And we are going to have such fun. Trace, what's in store for us today?
Okay, well, today we obviously doing grade 12. We're doing mechanics, so we're going to look at vertical motion, we're going to look at momentum, and then we're going to do the one the grade 12s absolutely love, work energy theorem.
Is that love?
Yeah, love.
Love. Okay.
They love it.
Guys, make sure that you're working through your book with us. We are so excited to have such an awesome lesson. I'm excited. I always get excited when I've got Tracy on because the energy is high. Guys, get off your couch, jump up and down. I know that a whole bunch of you are already on the page. That's facebook.com/learn extra. Also chat to us on Twitter. Do you want to take your spot at the board?
Get ready. There we go.
Yeah, you go get ready and I'll tell them about the competition.
Excellent.
Guys, I just want to say that thanks to Liberty for making this possible. You guys rock.
Ooh.
Let me just show you what the CDs that are up for grabs today. So what it is, it's the Ukutemba Songs of Hope, Trust and Belief, inspired by Mandela, and I see it's done by You and Drum Magazine. And then we've got Solistic Cuts, which is Volume 1 mixed by DJ Kabila. And then obviously, just so you can learn more and learn extra and ace those exams at the end of the year, we're also giving away an awesome textbook of your choice. This one is Physical Science, which is quite apt, considering it is physical science today. And then also this awesome I'm a Mindsetter t-shirt. So this is how you need to enter. What you need to do is you need to go to our events page, and it is our Winter School Grade 12's Wednesday the 4th of July, and please comment on our Winter School giveaway post. Another way that you can win, there are 3 other ways, and the other ways are you can email win@learnextra.co.za, or you can post in our PepText group, and the group code is LearnExtra, and you can get the free download from pepclub.mobi. That's www.pepclub.mobi, or SMS. Here's the number, and Tracy's shouting at me because this is such a mouthful. 083 44 888 10. Okay, I'm going to read the question out, and then we're going to pass the lesson straight over to the person who really needs to do a bit more talking, and that is Tracy. So guys, here is your question for today. Okay, the acceleration of... Ooh, am I doing the wrong one? Yes,
That's
right one. The acceleration of a ball at maximum height above the ground is... A, 0 meters seconds squared.
Meters per second squared.
Maybe you read it. You read it.
Okay, I'll read it for you. There we go. So, the acceleration of a ball at maximum height above the ground is A, 0 meters per second squared, B, 9.8 meters per second squared up, or C, 9.8 meters per second squared down.
And now it is time for you to begin the show.
Oh, thank you. Well, actually, it's a good competition question because we're going to go to projectile motion. So if you're listening while we do this, I'll actually get the answer to the competition question. Okay, so we've taken the question that we're doing from the February 2010 paper. All right, guys, the February-March papers are actually generally quite nice papers to do, though. They're generally a little more difficult than your November papers, so you don't want to do them by choice if you can at all help it, but they're nice ones to work through, and it's paper 1, question 5. Okay. The only thing about the February 2010 paper is just be careful. The order's a little strange because normally this would be question 3. It'll be first up in the mechanics section. They actually started with work, power, and energy for some reason, but it doesn't really matter. So as we go through it, what we're going to do is we're going to highlight and mark the important information because this has got a lot of stuff to it. It says to you that a supervisor who is 1.8 meters tall visits a construction site. A brick resting at the edge of a roof, which is 50 meters above the ground, and it's resting, so that's quite important, suddenly falls. At the instant when the brick has fallen, so it's already fallen 30 meters, the supervisor sees the brick coming down directly towards him from above. Ignore the effects of friction and take the downwards motion as positive. Now, there's a couple of really important things in this question. Number 1, they've said to you that you have to take down as positive. You don't have a choice here, grade 12s. Be very careful here. If you take up as positive, they're going to mark it wrong. They're giving you a sign direction. What I like to do, simply because, man, there was a lot of stuff in this. Let's draw a little picture. Now, we all know I can't draw, but that doesn't matter. So here we go. They said to us, here we have my brick, which is resting on the edge of a building. That building is 50 meters high, and we have a man, and I know it's not to scale, please ignore that, who is 1,8 meters high. The brick is resting, which means initial velocity is 0. Okay, and then they tell you that after it's fallen 30 meters, the supervisor realizes that the brick's coming towards him. Okay, and by then you start screaming and running. Now we can ignore friction, we like that. And they say, calculate the speed of the brick, okay, after it has fallen 30 meters. So they're saying to you, when it gets to this point, what is the brick's final velocity, okay? So now, easiest thing to do is we need to now write a list of all the information we're given. So we go, well, I'm going to do this. Maybe I should write signs for you. A, delta t. And now we use delta y. On your information sheets, you'll see that they use delta y and then that they use delta x, and then they say or, and they give you the same equation with delta y. Delta x is for horizontal motion, delta y is for vertical, okay? So we're dealing with something that's going up and down. Final velocity, which is what I'm looking for. Initial velocity, because it starts from rest, is 0. Okay, acceleration. Now, this is really important. Acceleration has to be acceleration due to gravity, okay? And what we need to remember is that no matter how an object moves, acceleration due to gravity always acts down, okay? Remember, the Earth attracts us to it, okay? If acceleration due to gravity had to act up, if we jumped, none of us would ever come back to the planet. And that, of course, would be a problem.
That would be a bummer.
Yeah, I do think most people don't live on Earth, but that's besides the point, okay? So, point is, acceleration due to gravity, only thing acting on my object. So it's 9,8 meters per second squared down, okay? That means it's a positive value because they told me down is my positive value. Then we go, I don't actually know how long it took to get to those 30 meters, but I do know that it's fallen 30 meters. So now we look at the equation, we go, well, okay, I want VF, I've got VI, I've got A, and I've got Y. You then look on your information sheet, you take out all the equations that have delta t in it because they don't help us, which means we're going to use this equation. VF squared equals VI squared plus 2A delta Y. Okay? That's the one we're going to work with. VF squared is what I'm looking for. VI is 0, so we like that. And we have 2 times 9,8 times 30. And I actually have what that works out to be, which is 588. But we're not done yet because that's VF squared. Okay, so now we've got to square root it. And we get 24,25 meters per second. They said speed, but obviously if you put your direction into there, it's not a train smash, you'd put that it's going down. Okay? So at this point, on my really bad diagram, we know that this is, wow. Let's do that. This is 24,25. Okay? So that's the first question done. Now they say to us, the average time of a human being, average reaction time is 0.4 seconds. In other words, what that means is, if something happens, it takes us 0.4 seconds to react before we're actually going to do anything about it, okay? With the aid of a suitable calculation, determine whether the supervisor will be able to avoid being hit by the brick. This is a very good question. Okay, so remember that the situation we have is this. The brick is now here. So this is 30 meters, which means the brick is 20 meters above the ground. My supervisor's over here. he is 1,8 meters, okay, and he's now seen the brick come towards him. He needs to know whether he's going to be able to get out of the way in time. What we know is that at this point, the brick is going at 24,25 meters per second. And the question is, if it takes this guy, takes him 0,4 seconds to react before he actually moves, okay, will he move in time? So we need to now determine whether that is sufficient time, or even better, it's a better way to look at this, goes, how long will it take for the brick to hit the man's head? Better question, okay? So we want to say to ourselves, okay, how long does it take for the brick to go from being 20 meters above the ground to the distance to the man's head, okay? So what we're actually asking ourselves is, how long does it take to fall that distance? So we want to know, ooh, we're doing well here. Okay, so the brick has to fall. It's 20 meters above. He's 1.8 meters above the ground. So the brick needs to fall. I'm not doing very well with the pen today, I'm just saying.
No, you're doing brilliantly, Tracy. Don't be so hard on yourself.
No, it's a moment. So the brick has to fall 18,2 meters. So what we need to work out is, if it takes less than 0.4 seconds to fall those 18,2 meters, then it's going to hit the man, okay? If it takes more than 0.4 seconds for those 18,2 meters, then it won't hit the man, okay? Simple as that. So the information we know is, well, we don't know final velocity because I don't know how fast it's going, but I do know that initially it's going 24,25. Okay, and I do know that the acceleration is still going to be 9,8. Okay, and I'm looking for time. So we look at this and we go, okay, I don't want to use VF because it means I'm going to have to work it out first, and if I can avoid working it out, let's avoid working it out. So we look at our equations and we go, all right, well, I could use, but I want to avoid this equation as well, because I could use that delta y equals vi delta. Let me show you let me write it down so you can see what I'm talking about. I could use this equation. Okay. But I'm hoping some of you are going, Tracy, that's a bad idea. And it's a completely bad idea from a maths point of view. If your maths is really, really strong, okay, and you know how to use the quadratic equation, okay, and you know how to use that funny little equation where you go minus b plus or minus square root of 4a, b squared minus 4ac over 2a, go ahead, okay, please, you're welcome to use it. I just don't suggest it. Though there's more than, actually we could use it another way, but we're not going to go into that. There's actually lots of ways to do this. What makes this so much fun? So what I'm saying is, with the information we've worked out, we're not going to do it this way, okay? Simply because I'm looking at this and I know that it's going to give me a horrible equation, and we don't want to do that because I'm lazy today. Okay, so we are going to go a little bit of the long way around, but that's okay, because I actually do need to work out what VF is. That's the first thing I need to do. So we're going to use the equation VF squared equals VI squared plus 2A delta Y, where VF squared is what I'm looking for. VI is 24,25 squared. Okay, and this is 9,8. We know it's going to go 18,2, and I actually worked this out earlier, and this gives me 944,78. So VF okay, so VF is 30.74 meters per second. So by the time it gets to the man's head, it's going 30.74 meters per second. That would kill him, basically, if it hits him. So this is not a good thing for it to happen. But the question is, does he have enough time? So I'm now going to go, well, let's do, oh man, okay. VF equals VI plus A delta T. We don't have a squaring here. We like it. It makes life a lot easier. So this is 30.74, 24.25, and I always run out of space. Okay, and that gives me, so because I did some of the maths earlier, 6.48. Okay, 0.66 seconds. Okay, now that 0.66 seconds says to me that the time it takes for my brick to go this distance is 0.66 seconds. Now remember, we said to you that his reaction time is 0.4 seconds. So that means it's going to have fallen for 0.4 seconds, then he's going to, and that's when it's when he's going to be able to move. So there's still a 0.26 second gap. So theoretically, he will get out the way. Of course, it means that he needs to take a really big step in either direction to miss his head. Okay, it might still hit the rest of him, but we're not going into what would happen in the real world because this is science. So theoretically speaking, he will avoid being struck on the head. Now, just quickly before we take a break, I want you to realize that there's always more than one way to do this question. I did this question looking at this last portion, okay, which was actually quite important because you could have, all right, I'm just going to talk you through this. I could have used this whole section, but the problem with using the whole section is I needed to know what that time at the top is. And nowhere over here did I work out how long it takes for those first 30 meters, okay? Because that's actually quite important because I could have used the whole section. Then I could have used delta y equals vi delta t plus a half a delta t squared, okay, and gone 50 minus 1,8, which means I would have used a distance of 48,2, but that time that I would have worked out would have then been for all of this. I then would have had to work out the time it takes for the first 30 meters and would have had to have minus the 2, okay, so be careful with what you work with. Rather simplify it down to the sections that make sense and the information given. So they said once it reaches at 30 meters, he sees it. So go from that section, okay? Also, you could have used quadratic equation. I actually hope some of you are going to redo this and try and use the quadratic equation and solve it, and you'll see you'll get the same answer. You need to understand there's always more than one answer, grade 12s, and you will always be given those options. When we mark, all those options are always there. You may not have used up as positive, though. That would have not been accepted ever for this question. And that brings us to
a break.
Yep.
That's a brilliant place for a break. Okay, I think I'm going to go get some coffee, guys. Keep your energy up. I know that you've all been watching since 9 a.m. this morning, and I think it's time to get a bit excited, get those bones working again. We are having such a great time. Well, I'm having such a great time on Facebook and on Twitter. Trace, there are so many people that's, it's the usuals. It's Sevi, it's Kashifa, it's Sia Dimo, but there are a few new faces and some old. We've even got a few mindsetters from last year, which is fantastic.
Brilliant.
Siyabonga, so glad you're joining in. Kamogelo, who else? Let me have a look here. Wise, guys, it's so awesome that you're joining. Get all of your friends to watch Learn Extra right now. We're going to take a break and we'll see you now. Hi guys, and welcome back to Winter School Grade 12s. I hope that you are all tuning in. I've just got a few wise words for you. If you join in at Winter School and you really understand and you ask questions and you really work hard, then finals are going to be a breeze. Never mind prelims. Prelims are going to be a walk in the park, and I think it's best that we learn more and learn extra as soon as possible. And I just wanted to give a quick shout out to Tiani, because Tiani used to be a mindsetter last year, and they've come back to say that Winter School was one of the best things that they could have done. So guys, I hope that you are all watching. Trace, first of all, big up to Liberty for making this possible. You guys absolutely rock, and thanks to Universal as well for these awesome CDs. And I see that you guys are all chatting on the page. Please let us know if you are struggling with anything, and at the end of the show, Tracy will be going through it. But let me not take any more time from your lesson, guys. Trace, take it away.
Brilliant. Okay, thank you.
Pleasure.
Guys, don't forget, we're still looking for answers to the competition question. Okay, and what we're going to do now is we're going to go into momentum. Now, for some of you, this is revision from grade 11. Okay, so that's always the fun part. Okay, once again, we're taking it from the February 2010 paper. It's question 4. Okay, paper 1. And we're just going to quickly go through it, all right? So it says to you, during an investigation, a police officer fires a bullet of mass 15 grams, so that's important, into a stationary wooden block of mass 5 kilograms suspended from a long, strong cord. The bullet remains stuck in the block, and the block bullet system swings to a height of 15 centimeters. Yellow went on holiday. 15 centimeters above the equilibrium position as shown below. Ignore the effects of friction and the mass of the cord. So that actually makes life a lot easier. And they drew us a diagram. We love it when they draw us diagrams. Okay, so we have our little bullet of 15 grams going into the block. It then swings. Okay, guys, first thing you need to remember that as soon as you have this motion, you have this pendulum swinging motion, it means that you may not use equations of motion. Okay, that's the first big important thing that you get. This is circular. Our equations of motion are only for linear motion, which means it's for horizontal or for vertical. Okay, they don't apply for when it goes in a circle. Now, first thing they want is state the law of conservation of momentum in words. That's nice and easy. There's one very important word in this particular definition that a lot of you leave out, and it says to us that in an isolated system, the total momentum of the system is conserved in both magnitude and direction. Okay? What are we looking for? In an isolated system. Okay, and it should be the total linear momentum is conserved. It's only worth 2 marks, grade 12s, but these are all or nothing marks. So it's a case of you don't get half marks because you got half right. You either get 0 or you get 2. You don't get anything in the middle. So please be careful. Do yourselves a favor. It's a little bit of a study hint, and it's a good thing for you to start now, is go through your books, and it's almost like you're going to make yourself a little dictionary. All right, I tell my learners to do the same, is every time you come across a definition or a law or anything like that, is you write it into this little book, and this is the last thing. So you're studying as you go along, and then the last thing you do before you actually finish studying is you learn all of these off by heart like a parrot. Okay, so, and you get someone to test you. So you've got to be able to say them backwards in your sleep. Why? Because 10% of your paper is this. So for some of you, that's a pass or a fail. That can change a symbol. Okay, important. Moving on. Now, they say to us, use energy principles. Grade 12s, I'm giving you the method. You use any other principles other than energy principles, they give you naught, because you're not answering the question. Okay, now, and a lot of times I get asked, but why does it matter? Well, it's the same thing as if you're applying for your ID, okay, which I'm sure most of you, well, hopefully you've all got because you needed to write your exams, is when you had to go to apply for your ID and it says date of birth. If you wrote the date that you applied for your ID, you're not going to get your ID because then it means you're 0 years old. Okay, so you can't just put any date. You have to put the date you were born on. Okay, it's the same thing. So I'm telling you what I want you to do. Says, show that the magnitude of the velocity of the bullet block system is 1,71 meters per second immediately after the bullet struck the block. That's what I want to show. That's where I need to get to. I don't use this answer. Okay? That's what I have to prove. So if we go back to our system, we go, well, I have two objects that are now going to collide. Okay? Brilliant. But before then, I've got to look and go, well, it's a collision system. I want to know what is the velocity over here, but I don't know anything about the bullet before we go, so we can't do it. And it said using energy principle, so I can't use momentum, which means I have to use the swinging motion. Okay? At the bottom, it's going to have a certain amount of kinetic energy, and at the top, it has a certain amount of potential energy. Layout is so important because we've got to remember, and I've run out of space, so I'm going to have to do it on another page, okay, that my mechanical energy, the mechanical energy at the bottom of the motion is equal to the mechanical energy at the top. Okay, so that means I've got to take potential plus kinetic at the bottom, and it's going to be equal to the potential plus the kinetic at the top. Please be careful here, grade 12s. Unfortunately, for a very long time, and it was accepted for a long time, where we could say kinetic at the bottom equals potential at the top. That's not accepted anymore because you have to show it this way around. Now, at the bottom, we recognize that the block is moving, okay, but there's no potential because it's at the bottom of its swing. Okay, at the top, there's no kinetic because it stops. Okay, now we need to recognize that our mass is the mass of the bullet plus the mass of the block, and remember the bullet was 15 grams. Ooh, and this just gets worse. So let's try write this so you can read it. How does that sound? Okay. Okay, Indy, the board.
Are you making a mess there, Tracy?
The board doesn't like me today, I'm just saying. So that's
I'm sure it does.
No, it doesn't.
Hey?
It's saying it's holiday.
Well, I actually want to say something to the mindsetters anyway, so then I can have a little bit of a... Guys, if you do want to phone into studio, you can. The number is 086 1058 262. So if you want to chat to us, you can phone. If there's a question, you can chat to me or Tracy live on air. I think Tracy's going to be able to help you a bit more than I will, but I like talking. So I don't mind. And if you are tuning in, please chat to us on Facebook, facebook.com/Learn Extra. Also chat to us on Twitter @Learn Extra. And don't forget about our great giveaways. If you have just tuned in, you can email win@learnextra.co.za with the answer to that challenge question, and don't forget the code. The code is, let me have a look here. Where are we? Physical science. The code is 4327. It also comes up during the breaks. And I see Tracy is ready for her lesson again. And you know how much I like to talk, so I'm going to hand it straight back over to Trace. Trace?
Okay, thank you.
Pleasure.
All right, now I've got board to listen to me. All right, now we've put in all the information I know. Distance was 15 centimeters, so I've changed it into meters. Please don't forget that. And I did all the maths beforehand because it's just easier. Okay, now I'm leaving all the decimals in because we're going to only round off at the end. Okay. And what I end up with there is that v squared equals 2,94. And when I square root this, I get 1,71 meters per second. Okay? It's a lot of work for 3 marks, but that's okay. All right, so that's the first one. Now, if we go back here and we go to the next question, which was, so we've done the first one, and we went, yay, we got that. calculate the magnitude of the velocity of the bullet just before it strikes the block. Now, grade 12, this is really important. If you didn't get that 1,71 meters per second, so you go and work it out and you didn't even get anywhere near that, that's okay. For 4.3, you say assume the velocity is 1,71 meters per second, okay? And then you move on. They're not going to carry down this error, grade 12s, because they've given you what the answer needed to be. That will always be right, okay? They're not going to say, go and work it out and show that it's equal to that, but it's not, because that's just silly. Now, this velocity over here, which now becomes my final, is 1,71. I have the bullet hitting the block. This is a momentum question. This is a conservation of momentum question, okay? And I'm going to do it on another page as well, because I don't quite have enough space, which means what I want is that the total momentum before equals, ooh, my word. Okay, total momentum. I think it's my nails.
Blaming it on the nails.
I
Hey?
think it likes the French manicure, I have to be honest. I think the white gets confused. Okay, but that's the point. Another way that you see this written, guys, and I know some of you, your teachers would have written it like that. They would have used the sigma sign. It doesn't matter, as long as it's the same. Okay, it's the same thing, it's just more than one way of writing the same thing, so we're not going to worry about that, okay? Pen, there we go. Beforehand, the block, so the bullet, let me write slowly. And the bullet and the block are two separate systems. Afterwards, they are the same system. Okay? The bullet has a mass of 0.15. We don't know its velocity. The block wasn't moving, so it's 0. We're going to add their masses together, and we know that they're going at 1,71. Okay? So now this becomes a maths problem, and we get 0,015. And this is 8,57. Okay. Now, this is a huge number, but it's the velocity of a bullet. So you know what? That's fine. If I'd got a tiny number, like say 57, I would have been worried, because it is a bullet, and remember, bullets move extremely quickly, which is why they're actually so dangerous. So, we have finished with question 2. Sorry, that was question 3. Question 4, last one. Now, the police officer is pushed slightly backwards by the butt of the rifle which he's holding against his shoulder whilst firing the rifle. Use the relevant law of motion to explain why this happens. Okay, now this happens with, now you see this in cop shows quite often. It's actually quite funny that you see their hands go backwards, okay, and in fact in movies they don't go as far back as they should because they use blanks, okay, so they don't use stuff, they still have a little bit of gunpowder, it's just not as much, so they don't do as much damage, but that means they don't have as much push. Now, relevant law, Newton's third law of motion. So somewhere in your answer you need to say, according to Newton's third law. So according to Newton's third law, what's going to happen is that the explosion happens inside the rifle, okay? That explosion causes a force on the bullet, which allows the bullet to go forwards, but Newton's third law says that there needs to be, if there's a force on body A, then body A must have a force on body B. So the explosion causes a force, so the rifle has the force on the bullet, and the bullet then pushes back on the rifle with the exact same force. Okay, so the rifle pushes backwards. That is our recoil. Okay, so recoil is because the gun essentially pushes forward on the bullet, and the bullet pushes back on the rifle. And it's the same, and I've changed, it's the same force, okay? So that's Newton's third law of motion. Relevant law, you must tell me what law you're using, grade 12s. You can't just say, well, according to Newton's, which one? Because it'll be 1, 2, or 3. All right, we're okay with that? And I think, Indy, we're done with that question. It's a good time for a break.
Let's do that. Let's take a break. Finally, I think I'm hopefully going to get a cup of coffee. Director intended. Okay, guys, please make sure you are joining in. And I know that I gave a number out earlier to phone. Don't phone with the challenge question. Phone with new questions. If there's anything that you are not understanding that Tracy's talking about, that you want to ask us about, please phone us on 086 1058 262, and that's if you have new questions with the work. And
I'll go through the challenge question at the end.
Yeah, we're going to go through the challenge question at the end in the last 15 minutes of the show, and that's when we will be announcing the winner as well. So what we're going to do, take a quick break, jump up and down, let's get your energy high to learn more and learn extra. See you now after the break. Hi guys, and welcome back. As you can see, I got my coffee. How well did that work? Hey? Thank you, John McBride, for watching Learn Extra Live and bringing me coffee. And thank you, Liberty, for making the show, making it awesome and making it possible. Guys, there are so many of you on the Facebook page and on Twitter. I'm loving chatting to all of you, especially Twitter. You're keeping me entertained. And Trace, I think we're going to have lots of questions for the end of the show, which is awesome. Keep them coming, guys. And also, I think the competition will be closing shortly, so make sure that you do get in your answers as quickly as possible. Trace, take it away.
Okay, brilliant. Actually, Indy, can I just, with regards to the book, guys, we're not doing the questions in the book, though. These are brilliant ones. In fact, it was actually quite funny because I hadn't seen the book, and I prepped a whole bunch of questions, and they were the ones in the book. Look at that. You see, we all think alike. But the answers, you'll find them during the winter school. They are going to be done at some stage, so don't worry about it. We're going to try and get these questions posted for you. We're busy trying to sort that out for you, so you're going to put it on the Facebook page?
We are indeed.
Okay, so we're going to try and sort it out for you guys. We are telling you which papers to get them from, so that also makes it a lot easier for you. But it's always good to have as much exposure as possible. Okay, so rather than doing the same questions over and over again, we're doing as many as we can. Now we get to the section that we all love. Love, yeah, that would
love.
be. Yeah, that's how my kids feel too. And, pretty much I think that's how everyone who works at my school feels when it comes to
but you're going to make
section.
them love it.
I
I believe in you.
It's really not as difficult as it looks.
Exactly, and if you say it, I believe it.
It is, and you know what the nice thing here, grade 12s, is we're starting to see a pattern. We're starting to see a trend in the way these questions are asked. So the more past papers you do, the more questions you do, the easier it's going to become, because you're going to realize that actually we can only ask this in so many ways, and then you'll be sorted. So they tell you, and this is from the February 2010 paper. It's actually a really nice one. It's question 6. A box of mass 60 kilograms starts from rest. Okay, so that's the first thing, is it starts from rest at a height h and slides down a rough slope, which means friction is an issue for us, which has a length of 10 meters. And it makes an angle of 25 degrees with the horizontal, and it undergoes a constant acceleration of magnitude 2 meters per second squared while sliding down the slope. Now, there's lots of nice pieces of information here. The fact that we have a constant acceleration means that we have a constant net force. Yay, it's going to make life easier. The angle's going to need to be used in a little while. We have 60 kilograms. We're going to go for it one step at a time. The first question is state the work energy theorem. Okay, this is just like with the law of conservation of momentum. And remember that it says to us that the net work done on an object is equal to the change in the object's kinetic energy. Okay, net work done equal to the change in kinetic energy. Now, why is that definition so important? Because net work done equals change in kinetic energy. It's actually straight from the equation, which we're going to need to use a little later on. Okay, now, first question. Now it says, draw a free body diagram to show all the forces acting on the cardboard box while it slides down the slope. Free body diagram, all the forces. Now, first thing we remember with a free body diagram. Free body diagram means we start with the object as a dot, okay? Second thing with a free body diagram is that all your forces must be drawn coming away from the object, okay? Nothing points in, everything points away. So let's start with the ones that make the most sense. Let's do an arrow that we can, so it's we'll do a yellow one, and the first one will be gravity, okay? Gravity. Guys, don't forget, let's put it here. Gravity has to be there, okay? Now, FG, guys, they asked for, draw a free body diagram. Always label it. This is the force of the earth on the object, okay? Nice and easy. Second thing is always, without exception, there's going to be your, and I'm actually going to say this to make sure it's yellow all the time, is there's going to be our normal force, okay? So here's my normal force. It's also written as an N, okay? That's fine, they'll accept that as well. And then, because we have friction, okay? Friction. That's enough. 3 marks. Please be careful here, grade 12s. I'm begging you. What a lot of you will now do is, because you realize that when it comes to doing calculations and stuff, is you look at this and you go, well, actually, you've been taught that there is, oh, no, let's just put that word. See, now I'm just moving things as well. Oh. Okay, okay, well, this arrow doesn't want to go back where it's supposed to, so let's leave it there. Okay, try that again, shall we? Now, you've been taught that that component, if your weight has components, which has a component, and I don't think you can actually, let's change that to green so you can actually see it, because that's pretty blue, but it doesn't work. Okay, and you also know that there's a component that comes down here, and you would write this as FG parallel, you write this as FG perpendicular, and then you get 0 for your question, because what I've done in green are components, okay? They're not actually the forces, and they said only the forces. Yes, I'm going to need those values a little later on, but I don't need that in the diagram because it's a component. So please be very careful. So only worth 3 marks, only need 3 forces. Okay, so next part of the question. So here we go, we're back there, and the box reaches the bottom of the slope. Yay! Calculate the following. Number 1, the kinetic energy of the box using the equations of motion. Okay, this is an interesting way around to do it, because we need to use equations of motion. They're being honest. They say, well, that's what you need to use. So we go, okay. Using equations of motion, we go back and we say, I know initial velocity is 0. Okay. And it's sliding down. I'm going to need to know final velocity, because I don't actually know. I actually want to move. Can I move this block? I just want to see if this is a separate block. No, okay. So, sorry. I'm going to need final velocity. They said to me it goes at a constant 2 meters per second squared, bonus, and I'm going to have to use delta x. The slope is 10 meters. So we go back to the question. 10 meters. Okay? It's linear. It's fine. It's not a problem. 2 meters per second squared. And it's gone black again, but that's okay. Oh, wonder why it's doing that. Anyway, so first thing we're going to do is we're going to work out final velocity. Let's make life easier. Squared. I'm not going to show all the maths because I'm actually going to run out of space on this one. So that's 0. And for those of you who are busy going, but why didn't we use 9,8? Because this isn't free fall, grade 12s. Okay, yes, it's moving down a slope, but it's not free fall. So it's not genuine vertical motion, okay? And it's a rough surface, which means friction's involved, so it can't be 9,8. So this gives me 400. We like that because then VF is exactly, where did they get 40 from? Sorry, that's 40, I'm lying to you. Should I? Okay. I think it's holiday time, hey, Indy? What do you think?
I think so too.
Okay.
For the board or for us?
For both. Anyway, all right. Now, what I'm actually going to do is I'm going to leave it like this because I'm going to show you why. Kinetic energy is a half mv squared. So we have 0.5. The box and stuff was 60. And watch here. V squared is 40. Okay, then I don't have to work it out again. So I'm just sort of being a little bit of a cheat there. So it's 1,200 joules. And once again, there's lots and lots and lots of ways around of doing that, okay? Now we get to the fun part. What is the work done on the box by the gravitational force? Okay, so we want work done on the box by the gravitational force. Okay, guys, this is where life gets interesting for you, because there's more than one way to do this, okay? So what we want to do is we need to look at this that makes the most sense. So what we're going to do is I'm actually going to look at the parallel version. Is I'm going to go, well, I can't use G as it stands because I don't know that height. Okay, if I knew that height, life would be really easy, but I don't. But I know the parallel distance, which means I need to know what the parallel component is. And you need to just learn this. Your parallel component is FG sine theta. Okay? So if we go back to this equation, okay, where I've got FG, I'm actually going to look at the parallel component. So I'm going to come back here and I'm going to go, well, I'm going to go FG. FG sine theta delta x cos theta. Okay, and yes, we're using theta 400 times. I'm sorry, it's just the way the equations are. So FG is going to be 60 times 9,8 times sine 25 times 10 times cos 0. Okay? And we plug all of that into our calculators and we get 2,485 joules. Okay? And now they want the work done by the frictional force using the work energy theorem. So now we're going to go, now life gets fun. Because we need to realize that our net work done is change in kinetic, okay? But your net work done is going to be the work done by the gravitational force plus the work done by friction, and that's going to give you your change in kinetic. Okay? That's your net. So, work done by gravity we've worked out. Work done by friction is what we want. And your change in kinetic is going to be final minus initial. So now we're going to have 2485 plus WF. And your final, you worked out earlier, was 1,200. Your initial, because it's not moving, is 0. So the work done by friction is minus 285. Now, some of you are busy going, how can work be negative? It's negative, and this is the easiest way to think about it because it's not useful. Okay? This work done by friction, that energy becomes heat. Okay? So it opposes the motion of the object, okay? And it's actually really important because now they want the frictional force, sorry, let's go back down. They want the frictional force, don't know how I did that. They want to know what friction is, okay? This negative is, is very important. Let's do that again. Extend page.
That's what happens when you have fancy nails, Trace.
Yeah, apparently. Okay. So, work done by friction. Note to self, never do it again.
Until we see you next week. You
Yes.
will do it again.
I'll paint them another color. Cos theta. Okay, so work done by friction. We've just worked out minus 1285. Force of friction is what I want. Okay. Goes 10 meters, and here is the trick, grade 12s. Friction is cos 180. Remember, objects move in this direction, friction pushes backwards. So the angle between the two is 180 degrees. Okay, so cos 180. Cos 180 is going to be minus. So that gives me minus 1285 equals minus 10 times the force of friction. So friction, 128,5 newtons. Okay, 128,5 newtons. So I know that I've got the correct answer because I end up with a positive answer over there. Okay, this was actually a really nice work in the energy question because it sort of separated it out into different sections. You just got to take it one section at a time. Please remember as well, grade 12s, that if you get one part wrong, it does get carried down, but you want to work carefully. And if this is a section you really, really hate, leave it till last. Okay, but you're going to get one, I promise, guaranteed. Definitely not even a if, but, or maybe about that. Okay, time for a break.
Let's go to a break. Fantastic, which is perfect timing because, guys, I want to let you know that after the break, the competition will be officially closed. And if you have missed how to enter, I want to give you that last chance so you can also win this awesome physics book, which can also be ordered from us at sales@mindset.co.za, just in case you were wondering. And these two awesome CDs and this Mindsetter t-shirt. So what you need to do is you need to watch in the break for the code. You need to send the code in, don't forget that. And just in case you were wondering, the code is 4327. You can email win@learnextra.co.za. You can post in our pep text group, that is Learn Extra, and go to peptext.mobi for the free download. Or you can SMS it to 083 44 888 10. And now for a break, and we'll see you when we get back. Hi guys, and welcome back. We are entering the last 30 minutes of our show. You guys asked for longer lessons, so that's exactly what we did. We gave you an hour and a half. Mindsetters, grade 10s, grade 12s, what am I talking about?
Because I normally do the grade 10s.
I know, you're confusing me, Tracy. Grade 12s, this show is for you. So guys, the competition is closed. I hope you got all of your answers in. By the looks of it on the page, there were lots of answers coming in. So what we're going to do is we're going to tackle the competition question now and chat about it, and then we will be announcing the winner towards the end of the show. So Trace, let's do that. Let's get on to it.
Brilliant. Thanks, Eddie. Okay, guys, this question is so, so important, okay? And it looks a lot simpler than it is. And it's a little bit of information that it's actually one of those things where, unfortunately, you get yourselves in a bit of a tiz, and it shows a real big misconception. Looking through some of the answers so far, I'm going, ooh, it's a little scary. But please, if you got it wrong, don't worry about it, because I promise you, even learners at my school and a lot of learners will have got this wrong, so please don't worry about it. The question was, the acceleration of a ball at a maximum height above the ground is. Now, I think most of you have realized that we were obviously talking about a situation where, say, we've thrown a ball up, it gets to this point, and then it's going to come back down. And you're confusing acceleration with velocity, okay? Yes, at its maximum height, velocity is 0, because it's going to have stopped. But the acceleration the ball experiences is due to gravity. Remember that gravity is here all the time. Gravity is because we live on the Earth. So we are attracted to the Earth. It's Newton's law of universal gravitation, and the Earth is attracted to us. We move towards the Earth because we're the smaller object, okay? And the Earth is far too big. Plus, the Earth's been attracted by all sorts of things. But what that means is at this point, the acceleration is still 9.8 meters per second squared down. The answer was C, okay? Because if it wasn't, if the ball got to its maximum height and now the acceleration was 0 and it's stationary, it would stay there. So every time you threw something up in the air, it would stay up in the air. Nothing would ever return back to the Earth. There's got to be something that's going to return it back to the Earth. That's our acceleration due to gravity, okay? So it's 9.8 meters per second squared down. Very important. It is always, always down. No exceptions. This is also something you've got to get, because I see this often. And I think it's just because you're so used to changing direction and you confuse acceleration with velocity, is that because it's changed direction, you think acceleration needs to change direction. No, it doesn't. Okay? Remember, it acts down, so as the object goes up, it slows down, but as the object comes down, because now it's in the same direction as the acceleration, it speeds up. Okay, so C was the answer, and we're going to announce the winner at the end, hey?
Yes.
Brilliant.
Because what we need to do, guys, is that they've been sending through SMS, through email, through pep text, and through Facebook. Okay. So what we do is we choose 2 right answers from each platform, and then we pick a number out of a hat, and
Brilliant.
then that's how it works. So, guys, we will be doing the last 15 minutes of the show.
Brilliant.
But I just want to go. We've got a question from a learner.
Brilliant.
While we're talking about this, guys, I'm going to ask Tracy now this question. But if you do have any questions that you want, please post them onto the page now, because now is the moment that we're going to get these questions and answer sessions going. Okay, Trace, let's have a look. Okay, so now this one is from Nguana, and she says, would I be wrong if I use delta x instead of delta y on my equation if the movement is vertical? Actually, and will I lose marks for the equation?
Okay, so if I'm understanding the question right, so if I gave you a question and you've got vertical motion, so you've got something moving up and down, okay, and you wanted to use, say, this equation, and you decided to use delta x instead of delta y. It's a tough question to actually answer, because in reality you should actually lose marks for that, Speedy, simply because this is displacement in the x direction. Okay, and remember, we're using the Cartesian plane like you do in maths, where x is horizontal and y is vertical. Okay, now because we have decided not to do 2-dimensional motion, it's been taken out of your curriculum, and we're very grateful for that. You're never ever going to have to use both at the same time, but you really should get used to using delta x for horizontal and delta y for vertical. The nice thing about grade 12 is that your equations of motion, generally speaking, will be using delta y, because it's very specific in your curriculum that it's vertical motion only. You might need to use delta x when we add a little momentum into it and it's horizontal, but rather, if you're going to forget, draw something like this on your information sheet right at the beginning of the exam to remind yourself that horizontal is X, vertical is Y, and rather be on the safe side. Okay, because sometimes we can accept the delta X and sometimes we can't. It all depends on the external moderator and the external examiner, and rather be safe than sorry.
Awesome.
I think
Okay.
that's a much better idea.
Trace,
Yeah.
the question is on Smart if you want to get that up in the meantime.
Okay.
Guys, I just wanted to let you know, because a whole bunch of you, obviously, one lucky person is going to be winning this awesome book, as well as the CD and as well as the T-shirt. But guys, we are selling the T-shirts as well as these books. And what you need to do is you can email sales@mindset.co.za, or you can even jump on over to our website and go to the Order DVDs and Books tab, and there you can download our catalog and our order form. So I'm going to post that onto the Facebook page so you do have that on hand. I'm just
Great.
making sure. Trace, are you having a few problems?
I am. It's okay.
That's okay.
It's just
So guys,
Close
also I
ink
want to tell you guys that you can please send in your questions. We've still got 20 minutes left in the show, and we want to help you guys learn
I'm going
more
to ad break.
and learn extra. What we're going to do is we're going to take a little ad break, but that gives you a nice time to get up and just get yourself revitalized and re-energized. I know that you've been watching since 9 a.m., but it's really important that you do get all of this revision in, and I promise you at the end of the year you guys are going to rock those finals like you have no idea. Okay guys, see you now after the break. Hi guys, and welcome back to Winter School. We are going into the last 17 minutes of the grade 12 show, and it's physics. Hope you haven't just tuned in now, and hope you have been watching the entire time.
me too, actually. So you will be lost.
Okay, so Sia Demore, we have I have called in the troops for help.
Yes.
Yeah. So
'Cause
here's the question. Here's the question, Trace. Let me just go in closer.
It's making it a bit bigger for
I'm
me.
making it
'cause
bigger.
It's old
There
age.
you go.
Yeah, she's struggling a little with it's fine, but it's okay, Indy. We
Just
understand.
carry on.
Anyway, so Sia Demore.
Sia Demore. Sia Demore.
Sia Demore.
It took me long enough to get that, and she knows. She shouts at me on the page all the time.
Brilliant. I know.
All the time.
So it says, can somebody please explain to me, I really like the font, by the way,
Always beautiful fonts.
Yeah.
Sia Demore's always got beautiful fonts.
why network is work done by gravity plus work done by friction and not just work done by friction. Sia Demore, that's actually Demo.
Demore.
Okay, that's a good
'Kay,
question.
you
I'm going to go back
across.
this way.
Okay, she's going across. Sia Demore.
Let's
Hope
go
you're
back here.
watching.
Because your question comes from here, all right? Now, this is actually a very important question. Your network for this question is important. It is never going to just be work done by friction, okay? Because you are always going to have some other force. Remember, friction acts against the motion, all right? So you have to have another force. It can be, network can just be work done by gravity if there's no friction involved. Network means that I'm taking into account the work done by all the forces acting on the object, okay? It's the same concept as looking at net force. Another way round to doing this question is we could have actually gone and instead of working out WG, because that was actually in the question, we could have actually first worked out what F net was. And remember, F net would have been your F plus work done by friction. Okay? Now, in this particular question, I couldn't do it because I needed to know what the frictional force was, which we didn't know until the next question. Okay? But your net work is the work done by the net force, and that must be all the forces that are involved on the parallel section. Okay? So I'm hoping that helps for you, sweetie, but it's never, ever going to just be work done by friction. Ever. It can just be work done by gravity, because if there's no friction, then that's fine, but never just by friction. Okay, so I really hope that helps you. Now, what we've got is we've got a couple of multiple choice questions, which I'm actually really happy about, because this is probably the one section we never spend a lot of time doing, but it's actually quite important, because these questions come up all the time, and let's be honest, grade 12s, we play multiple guess or we leave them out. Please don't leave them out. I jump on my learners at school when they leave out multiple choice because, you know what? If you don't know,
take a chance. Take a chance.
take a chance.
It's kind of like the saying, if you don't buy the lotto ticket,
Then
don't
you'll never
complain
win.
that you never win.
Absolutely. And you know what? You've got a 1 in 4 chance of getting it right. 1 in 4 is better than naught. You agree? Brilliant. So, first question. And this we actually took from the 2012 February paper. So it's the newest one that's just come out. Okay. And it says to you, a car of mass m collides head-on with a truck of mass 2m, and if the car exerts a force of magnitude F on the truck during the collision, the magnitude of the force that the truck exerts on the car is. So, this is exactly how I tell my learners to do this in my class. We go, okay, car, mass m, collides head-on with a truck, mass 2m. We exert a force of F. What is the force on the truck? Okay, first of all, the mass of the car and the truck, irrelevant. Guys, this is Newton's third law. It's what we were talking about with the rifle and the bullets. Okay? A lot of you will be going, oh, wait, truck's 2m, it's got to be 2F. No, of course not. Okay, just because you have less damage if you're in the truck, doesn't mean you experience a smaller force. It's because you accelerate less. Okay? The answer is B, because whatever force the truck exerts on the car exerts on the truck, and the other way around. Okay? Newton's third law. Very important. Number 2. So, an object moves in a straight line on a rough horizontal surface. Friction's involved. If the work done on the object is 0, net work done is 0, then, okay, let's think about what they're saying. They're saying to us that net work equals 0, okay, and net work is our change in kinetic energy. The object is moving, so it has to have some sort of kinetic energy. So now we look at the specific, we're going to look at the options. The object has 0 kinetic energy. Well, that makes no sense because the object's moving. Okay, so that's just silly. We can't use that one. The object moves at constant speed. That could be a possibility. The object moves at constant acceleration. If it's constant acceleration, that means it's speeding up, which then means there will be a change in kinetic energy. So the net work done can't be 0, so it's not that one. There is no frictional force acting on the object. Well, that can't be true either, because they told me it was a rough horizontal surface, so it's not. The answer has to be B. Okay. Guys, I'm hoping you're paying attention to how I'm working these out. I'm not just looking for a random answer, and I'm actually thinking through all the possibilities, because each of these options show us a misconception. So when your teachers mark this, we can see what your misconception is. But if you chose A, then we actually understand that you don't really know what kinetic energy is. Or if you said C, then we know that you're not realizing what net work means and what a change in acceleration means. Okay, so we're actually getting there a little bit. So now we get to the fun one with graphs, which you guys all don't really like. Anyway.
Everyone's like, meh.
Yeah, pretty much. Everyone's going, no, please don't. There we go. A ball is released from rest from a certain height above the floor and bounces off the floor a number of times. Ignore the effect of air resistance. Yay, we like that. Which one, so only one of these is right, of the following velocity time graphs best represents the motion of the ball? So now, in our heads, before we even look at these, we go, okay, ball being dropped, okay, starts from rest. Okay, so let's first look at our graphs and go, well, can't be D then, because D, velocity doesn't start from rest. So D is not an option. Okay, starts from rest, starts from rest, starts from rest. Brilliant. Okay, ball starts from rest, going to speed up, because we just spoke about the acceleration, so it gets faster and faster and faster, hits the floor, then it's going to change direction. Okay, now we obviously means that I'm going to have a positive direction and a negative direction because it goes down and then it comes up. So that means we have to have a graph that has a positive and a negative side to it. So B is not an option. Okay, so we're busy eliminating them. And we go, okay, fine. So it goes up. It's going to hit the floor. It changes direction, comes up again, and then changes direction and goes down, hits the floor. Okay, cool. Now, next thing we got to, so these are starting to look sort of right. But now we've got to say to ourselves, all right, what do we know about the acceleration? It's acceleration due to gravity, which always acts down, always 9.8. It is a constant value. Constant acceleration means that we have to get a straight line graph, okay? This shape, first of all, it is a curve, okay? That curve says to me that the acceleration is not constant, okay? The acceleration is changing, and you do not work with changing acceleration at school level, first of all, for calculations. Second of all, what this graph is actually telling me is that it speeds up, it speeds up, it speeds up, it gets to a maximum, and then it slows down before it gets to 0 again. There's no change in direction in that second part of the graph. That is not what is happening, okay? So that doesn't help me at all. And it's a curve, so it can't be A. Can it be C? Because, well, it's the only one left anyway, but it has to be C because my velocity increases till it gets to its maximum and hits the floor, changes direction instantly, okay? Now it goes upwards, reaches the top of its motion, changes direction, it's hitting the floor again, changes direction, okay? And in fact, this one bounced twice. All right, so be careful here. And I'm hoping you were listening to the way we worked through this, where we looked at all the clues, like it started from rest, so D couldn't have been an option. It's bouncing up and down, which means it has to change direction, which means B isn't an option, okay? And then we looked at the shape of the graph. Very, very important. Indeed, do we have some questions?
We do!
Oh, yay, okay.
Yay. Okay, are you ready?
I'm ready.
Okay, let us start from the very beginning.
Okay.
Okay, just opening up. And let me just have a look here. I think we might even have confirmation. I know who the winner is.
Oh, yeah, I don't, so.
I do. And guys, I just got this message from John. And obviously, like I told you before, 2 correct answers are chosen from the email, from pep text, from Facebook. And so, okay, should we do it now? I might as well. I'm just too excited.
She's like,
sorry.
Okay.
Okay, the winner is Ashworth Lebojo. So, and it's quite
well
exciting
done,
because I talk to him on Facebook all the time. So I'm so
Brilliant.
happy for him. Please, will you email us win@learnextra, the size of your T-shirt. Also, which book you would like. And don't forget that you are getting these 2 awesome TVs.
TVs, okay.
CDs. Solistic cuts, as well as Ukutemba Songs of Hope, Trust and Belief. And I think your parents might like this one. It's got Ladysmith Black Mambazo, Huma, Sakela,
and with
some Pee-wee Dana, Sipo Hot Sticks. So it's really, really awesome.
And considering it's his birthday quite soon, I think it's wonderful.
I think it's fantastic.
Brilliant.
Okay, let's have a look and see what questions.
Okay.
Okay, this one's from Sibongile, and she says, if the equations of motion, will I be wrong if I substitute acceleration as G instead of A?
No, you won't be. I just never teach it as G, and I keep it as an A, but it's fine. So if you wrote it, but only if it's vertical motion, hey? If it's in any other context, it is wrong. But if it's vertical motion and you write it like this, it's fine. It's not a problem because it's just a specific value for it. So that's perfect. Not an issue.
Okay.
Mm-hmm.
Okay, this one is from, I think her name's Toomey, but it's Kid Toomey, Hope McCoffey. She says, I'm only gonna ask one question, because she's got two here.
Yeah.
Why is the normal force and frictional force drawn at an angle on 6.2?
Okay, because the object was on a slope, okay? So because my object was on the slope, which is what I didn't draw, remember your normal force is always perpendicular to the surface, so whatever surface it is, so that's why it goes up, and friction is always parallel to your surface, which is why it went up in that direction, whereas gravity always acts vertically down. So that's why it's at an angle, because I didn't draw the slope into it, but it's from the slope. Okay, so your normal force and your frictional force are always, so frictional's parallel, normal's always perpendicular. And in fact, those two are always, if I'm not moving them around, those two are actually at right angles to each other.
Awesome.
Yeah.
Okay. And I just want to tell all the mindsetters why I didn't ask the second question. So the second question was, can you please explain from 6.2.3, because she doesn't understand it all. Guys, what I need you to do is when you send your questions in, please show us where you aren't understanding and where you're not understanding, because it makes our job much faster and we can actually answer more questions at a faster pace.
And I would say too, for something like that, is eventually this is going to end up on YouTube, is it not?
Yeah.
So,
Yeah.
sweetie, wait a couple of days, download it, and rewatch it. I think that's the easiest way to do it, because I'm just going to I'll explain it exactly the same way. So wait a couple of days, go into YouTube, download it, and then just rewatch, because then you can watch it like 400 times if you really want to.
Exactly.
That'd be a bit scary.
That's really good advice. And what we will do is that after the show, I will be posting the link to our YouTube channel if you're not watching it already.
Yes.
Okay, let's have a look here. Okay, this one's from Kabi Singh, and she says, Indy, please ask, why did Tracy leave question 3.2 as 40?
Okay, that's just because I was being lazy, and I left it as 40. No, it's a good question. Okay. I left it as 40 because if you look back here, that was actually on the work, energy, and power. Okay. I left it as 40. If we go over here, this is the one she wanted, because I knew that I was going to take this VF squared and put it into the equation where I V squared it anyway. So I could have changed it, found what 40 square rooted was, but I'm just going to have to square it anyway, and it gives me 40. So I was actually just being a little lazy.
Ach no, Tracy. No. Okay, I think we've literally got one more second for one more question.
Okay, so I got 30 seconds.
Quickly. Yeah. Okay, so now this one is from Twitter, and this one was from Lesedi. When drawing the free body diagrams, do the lengths of the arrows make a difference?
Only if they have to be exactly the same size, but no. Generally, relative sizes are fine, and we also didn't know the size of the normal force or the frictional force, so no. Just don't draw them like ridiculously out of proportion. We sort of draw them around about the same sort of sizes, but no, they don't. It's fine.
Okay.
Yeah.
Okay, fantastic. So guys, thank you so much for joining in. Well done, Ashworth. I'm so glad that you won that, and I think it's really, really, really cool. We've had such an awesome lesson, guys. I've had the best time ever. I actually wish I was doing the later session, but Ty will be in for the later session. Don't forget that at 3 o'clock we do have live life science, and that is paper 1, DNA and RNA. So guys, please make sure that you are joining in to learn more, learn extra. Join us on facebook.com/learn extra. Also chat to us on Twitter @learn extra. We've had the most amazing time. Trace, thank you for an awesome lesson.
It was nice to be back in the studio.
Yeah. Okay, guys, thanks for learning more, learning extra. See you same time, same place. Bye.